Good morning to all of you and welcome to Chopra's School of Physics. I hope by this time you are acquainted with the units, and now you must be acquainted with certain important formulas like the formula of Coulomb force, the formula of electrostatic potential, and the formula of capacitance. They are serious applications as well as the MKS applications. Now, first of all, we will write Coulomb's formula. We will use both the systems, the CGS as well as SI or MKS units. So, if we wanted to use the CGS formula of Coulomb's law, we simply write like this, that is F is equal to Q1, Q2 divided by R square. Here F stands for electrical force. Electrical force between the two charges. Between two charges. Q1 stands for charge, Q2 also stands for charge. And Q1 and Q2, they are separated by distance R. Like if one charge is Q1 here, other charge is Q2 here, their separation, that is R. And we must know that in which medium the charges are kept. That's very important. So here our assumption is the medium is air or vacuum. The medium is air or vacuum. So what you should ask me now, which you are not asking? You must ask me, when I am saying air here, then how it can be vacuum? Because when we speak vacuum, there must not be any air trace. Means totally air will be absent. But in many cases we take the approximations. Like for example, we say that we have taken out a drop of water from ocean. And we will say what is the change in volume of the ocean. It's a very ridiculous question. Because it is like that we must know the whole volume of the ocean, and then we must know what is the volume of drop. Then the volume of drop is to be subtracted from the volume of ocean, and that remaining number will become the remaining water in the ocean. Now, if the amount of water in the ocean is of the order of 10 to the power 40, and the drop is of the order of 10 to the power minus 2, can we make a proper subtraction in these two numbers? It is 1 over 100. 10 to the power 40 minus 1 over 100, not possible. Means it's a very, very small quantity, and normally the small quantities are written in terms of delta x. Like if we take the difference of the two numbers, it will be like this, delta x and delta x approaching to 0. Very, very close to 0. So such numbers we ignore. We don't take into consideration such type of numbers. We take the nearest approximation. So here F is Q1, Q2 by R square. Medium is air or vacuum because the density of air is very small. The density of air, density, D stands for density. density of air. 0.001293 grams per centimeter cube. After decimal, we are having two zeros. The number is negligible, very small. So if you compare the densities for air or vacuum, air is almost a vacuum, or rather you can say a partial vacuum. So we have written here, the medium is either air or vacuum. If the medium is not specified in any of the question, we must assume that it should be either vacuum or air. I hope this point is clear to you. And now it is the formula in CDS system. Now here, these are the two charges. The charges Q1 and Q2. They must be taken in electrostatic unit of charge. R must be taken in centimeters. And force must be calculated in dynes. Dynes CDS unit. It is CDS unit of force. What is the MKS unit of force? The MKS unit of force, that is taken as force in MKS units, Newton. So in the lower classes, you have learned about these two units like dynes and newtons. But here now, we have to apply them only. You will remember, 1 Newton is 10 to the power 5 dynes, and 1 dyne, that is 10 to the power minus 5 newtons. Newtons and dynes. Newtons and dynes are absolute units of force. Absolute. What exactly is the meaning of absolute units? The practical units. Absolute units means practical units. So these are some units. So F must be in dynes or newtons, Q1 and Q2 must be in ESU, and R must be in centimeters. So this is how we use this formula. So if we put here the values, then all calculations will be in CGS system. The formula is used in CGS system. So I hope this formula is clear to you. And now another thing which you will remember, that is F is given by another formula, that is K Q1 Q2 divided by R square. This formula I have written in MKS system or SI system. So what's the difference? Here we have taken a constant. This constant K, here we have not taken. So here the simple rule to remember, when we are not using this constant, it means CDS concept is used, and when we are using K here, it means it should be MKS system. And you will further remember, K is electrical constant of air or vacuum. We are again using air or vacuum. We are considering air as vacuum because very small density. It's a partial vacuum. But now we can also use a single term for air or vacuum, And the single term for air or vacuum is known as free space. So normally in your books when you read and in the questions, you will find that most of the time we are using the term free space. So free space is nothing, you must not be confused. It should be taken as air or vacuum. That's what the meaning of free space. And electrical constant of air, that is taken as 9 into 10 to the power 9. 9 into 10 to the power 9. Now, unit is very important. So it is K is electrical constant, 9 into 10 to the power 9, and this is Newton meter square per Coulomb square. So the value of electrical constant, 9 into 10 to the power 9 Newton meter square per Coulomb square. So the unit is very important. If you don't remember the units, it is very difficult to convert one formula into another formula, or one unit into another unit. So what I have explained you here, that is force is the product of charges divided by square of distance, and Q1 and Q2 are the two charges and they are separated by a distance r. Medium is air, and here in MKS we are using K, Q1, Q2 by r square. K is electrical constant of air or vacuum. The value of electrical constant, 9 into 10 to the power 9 Newton meter square per Coulomb square. Air or vacuum, they are also known as free space. So in any question where free space is written, our assumption will be that it is air or vacuum. Another thing that you remember, the series unit of force, and that is dynes, and MKS unit of force is Newton. Their relation is 1 Newton is 10 to the power 5 dynes, or 1 dyne 10 to the power minus 5 newtons. Newtons and dynes, they are absolute units of force or the practical units of force. I hope this formula is clear to you. Now there is another formula, that is the formula of electrostatic potential in MKS unit as well as in CDS units. So the formula of potential will be like this: V is equal to Q divided by R. This is called CGS representation. So now I have written V for potential, Q for charge, and R, that is the distance at which the potential is to be estimated. So V is Q by R, this is the CDS unit, and you will remember here the charge must be taken in electrostatic unit of charge. R must be taken in centimeters. V must be taken in electrostatic unit of potential. One electrostatic unit of potential is 1 ESU of charge divided by 1 centimeter. It's like that. MKS unit, potential written as K Q over R. As I have explained you earlier, K is electrical constant of air or vacuum. I will slightly elaborate more, like whether we are using it here in this formula or in this formula. The formula which we have earlier written, this formula or this formula, series or MKS, they are basically known as the Coulomb's law of electrical force. So the formula is named as Coulomb's law of electrical force. This formula also known as Coulomb's law of electrical force. So Coulomb's law of electrical force, and this is called potential. Potential is the work done to bring unit positive charge from infinity to that point which is within the electric field. That is what the meaning of potential. It is the work done. So, you remember here that V will be taken in volts, charge in coulombs, R in meters, and K, that is 9 into 10 to the power 9 Newton meter square per Coulomb square. You may be wondering that how exactly we get this value. You will remember that value of K is taken as 1 over 4 pi epsilon naught. I have written electrical constant, pi is constant, epsilon naught. This symbol is normally known as epsilon. And epsilon, this sum, this is 0, so epsilon naught. This is called absolute permittivity of medium. Absolute permittivity of medium. In our coming videos, I will elaborate the concept of permittivity and permeability, and then we will explain how to get a formula of the velocity of light, like how to get the formula of electromagnetic waves. So K is 1 by 4 pi epsilon naught. Epsilon naught, this we have written, the meaning is absolute permittivity of medium. Now when we use epsilon naught here, epsilon naught for air or vacuum, it is taken as 8.854 10 to the power minus 12 Coulomb square per Newton meter square. So for absolute permittivity, what is the unit? Coulomb square per Newton meter square. Now if you put this number here in this position and pi is taken as 3.14 up to 2 decimal places, or we can take it as 22 by 7. For pi you should put this number, for epsilon naught you should put this number, and the value of K is calculated as, in approximation, 9 into 10 to the power 9. Now we have to write unit. Epsilon naught is in the denominator. So if you put this number in the denominator, Newton meter square will come in the numerator and Coulomb square in denominator. So here I have written here Newton meter square in numerator and Coulomb square in denominator. So you will remember that electrical constant of air is this one, epsilon naught for air, this one, pi 3.14 or 22 by 7. If you compute here epsilon naught, this number, and pi as this number, and you make the calculation, I hope the calculations are known to you, how to make the division and multiplication. You have learned in the earlier classes, like in the primary classes we are aware of how to multiply the numbers or how to divide the numbers. So I think that I must not explain you how to multiply or divide, rather we are going to compute the value and we come to the final conclusion that K must be 9 into 10 to the power 9 Newton meter square per Coulomb square. So this is how we use the concepts of potential. So now you are aware of the formula of the Coulomb's law, and the formula of the potentials and different type of symbols which we use. So after this, in the next continuation, in the next video, I will explain you about the, the formula of capacitance, and then we will correlate all the three numbers. Right? Thank you very much.